Let us discuss the classification of group of forces. Group of forces means two or more forces. So we can say when two or more forces act on a body, then based on its state of motion, these forces are classified in two categories. These are, the very first one is balanced forces, and the second one is unbalanced forces. As the name implies, you can say when two or more forces act on a body, and if summation of all force vector acting on the body is equal to 0, say if 10 forces are acting F1 plus F2 up to Fn, if sum of this is equal to 0, that implies acceleration of body is also equal to 0. So acceleration is 0, that means V vector is a constant. Velocity is not changing, that means the state of motion is not changing. That means either body will be at rest or the body will be in uniform motion. So both of these conditions imply that if two or more forces are acting on the body, their vector sum is equals to 0, or you can simply say the forces are balanced. This condition we call equilibrium. Equilibrium implies the net force acting on the body is equal to 0. If body is at rest, it is termed as static equilibrium because body is static and net forces acting on the body is 0. About a static equilibrium, we'll discuss in detail in the upcoming chapters also. If we talk about unbalanced forces, it simply states that net sum of all forces acting on body is non-zero. If net forces acting on body is non-zero, we can simply state the body will be in accelerated motion. And as you earlier studied in previous classes, that the total acceleration of body can be written as sum of all forces acting on body upon mass of body. So whenever unbalanced forces act on a body, if forces are not balanced, the body will be in accelerated motion. That means velocity vector changes. If this vector is changing, it may change direction, it may change both magnitude and direction. So whenever two or more forces act on a body, we state forces will be either balanced or unbalanced. These are the two broad categories under which group of forces can be classified. In sequence, let us talk something about static equilibrium. It says when under the action of two or more forces, a body is at rest, then it is said to be in static equilibrium. As we have discussed, equilibrium implies net sum of all forces acting on body is equals to 0. Simultaneously, if body is at rest, then it is said to be in static equilibrium. Like for the simplest example, if we are having a body and it is kept at rest, and if two forces are acting on it, one is F1, other is F2 in opposite directions. So at rest, obviously net force acting on it must be 0. So we can simply write F1 is equals to F2. Vectorially, we can write F1 minus F2 is equals to 0, or we can directly write F1 is equals to F2, as the two forces would be balancing each other. Another simple example we can say, if a body is hanging from a string, it is hanging from a string which is tied up, the other end of the string is tied up at the ceiling. In this situation, again the body is at rest. The body would be experiencing its weight mg in downward direction. and the tension in the string, or you can say when a string will be tight due to mg, it will exert a force F on the body. If it is at rest, again we can write the force F, which is due to the tension in the string, must be equals to the weight of body, then only the body will be at rest. Such type of detailed analysis about a static equilibrium we'll discuss, but step by step we'll be approaching the different type of cases. So let's see one more case of a static equilibrium under the action of three forces. You can simply state when a body is under the state of equilibrium in the influence of three forces, then we can directly state if body is under the state of equilibrium in the influence of three forces, then vector sum of these three forces must be 0. So we can simply state then these forces must successively represent the sides of a triangle. So this is the basic triangle rule of vector addition. Whenever three vectors represent successive sides of a triangle, their vector sum is equal to 0. So if this is a vector f1, this is another vector f2, and this is a vector f3, you can simply state f1 vector plus f2 vector plus f3 vector is equal to 0. If these three forces are acting on a single body, so it is experiencing f1 in this direction, it is experiencing f2 in this direction, and f3 in this direction. And if body is kept at rest or it is under the state of equilibrium, then we can simply state the three sides represents, or three forces represents the three sides of a triangle. In this situation, in case of a triangle, we can also use sine rule. In this situation, if we apply sine rule, say the angle opposite to f1 is theta 1, opposite to f2 is theta 2, and opposite to f3 is theta 3. So in this situation, these are the angles which we can use: pi minus theta 3, pi minus theta 2, and pi minus theta 1. So in this situation, we define a separate theorem which we call Lami's theorem, which relates the forces with the angle between the direction of force vector, and this is indirectly sine rule applied on the triangle, and it can be mathematically written as f1 upon sine theta 1 is equals to f2 upon sine theta 2 is equals to f3 upon sine theta 3. This is the expression for Lami's theorem, and this Lami's theorem is used in analysis of various forces and the angle between the direction of force vectors. If you directly apply sine rule in this triangle, you will directly get this. As in sine rule, you use the ratio of the magnitude of one side to the sine of the angle in the triangle opposite to that side remains constant. So as this is f3, this angle will be pi minus theta 3. As this is theta 3, we can simply write this angle between f1 and f2 vector will be in succession pi minus theta 3. So f3 upon sine pi minus theta 3, which is obviously f3 upon sine theta 3, is equal to f2 upon sine of pi minus theta 2 and is equals to f1 upon sine of pi minus theta 1. This will directly result this Lami's theorem. So be careful, Lami's theorem is used whenever three forces are acting on a body and the body is under the state of rest or it is in the state of equilibrium. This can be directly used. So be careful about this. In several applications we are going to use Lami's theorem directly.